Now we are going to discuss the multiplication and the division program, because in 8085 you know that you don't have any instruction by which you are able to do multiplication operation or the division operation. So for doing arithmetic operation like multiplication and division, since no instructions are available in 8085 because of the restriction, for doing the multiplication we have to go for writing a program for the multiplication. Now a very simple fundamental is being used for the multiplication purpose. In the multiplication we have two things which is very important. One is multiplier and other is multiplicand. So if we don't know that how to multiply the number, and we know the multiplicand as well as the multiplier, so the other option is to add the multiplier as many as time to add the multiplicand as many as time the multiplier is. Suppose we have multiplicand as 7 and multiplier is 2. So if we know the mathematics that how to multiply these two numbers, so 7 into 2 it will become 14. But if we don't know that how the multiplication is being done, then what we can do, we know the multiplier value, we also know the multiplicand value. So why not to add the multiplicand to itself by number of times as the value of multiplier is. So if you multiply 7 with 2, you will get 14. But if you add 7 2 times with itself, you will be getting 14. So with the same fundamental, the multiplication program is being written. So first of all, we will discuss the flowchart of multiplication. We start and try to find out what is the multiplier value and what is the multiplicand value, and we initialize the result wherever we are going to store the result. We initialize that result by 0 0, and then what we'll do, we will add the multiplier with the result. Actually it is not the multiplier, it should be the multiplicand, because then we have to decrement the multiplier, and if the multiplier becomes 0, then we will store the result, and we will start this loop till the multiplier becomes 0. If it is not 0, we will again do the same process. So 7 is to be multiplied by 2, so 7 is the multiplicand and multiplier is 2. So what we will do, we will store the result as 0 0. We will add 7 with 0. In this flowchart there is some mistake. It should be result is equal to result plus multiplicand. It should not be multiplier, and then we will reducing the multiplier one by one. So once the first phase is when the result is 0, which is initialized. So result is 0, so the next value of the result will be 0 plus the multiplicand, that is 7. So 0 0 plus 7, it will become 7. The result will become 7. Now the decrement the multiplier, so multiplier is 2, it will decrement, it will become 1. Since the multiplier is not 0, it will go back, and then it will add result is equal to result plus multiplicand. So multiplicand is again 7, so previous result is 7, 7 plus 7, it will become 14. Now decrement multiplier, now multiplier was 1 and it will become 0. So since the multiplier has become 0, so it will not go into the loop, it will come out and store the result. Now let us discuss the program related with this flowchart. So whatever is the multiplier value, it is first stored in the C register. C register is used for storing the multiplier, and the multiplicand has been stored in the 16-bit D pair register. Why 16-bit has been used? Because it may be possible that whenever we multiply an 8-bit number by an 8-bit number, there is a possibility that the result which we will be getting, that will be a 16-bit number. So why not to put this multiplicand into a 16-bit register? And then we have initialized the HL pair by 0 0 0 0. Now in the previous slide and the video, you have seen instruction DAD, whose purpose is to add the register pair with the register pair and store the result in the HL pair. So what D will be doing, now in D pair register we have multiplicand. Of course the multiplicand is 8-bit, so suppose the multiplicand value is 0 7, and we will store it in the D pair register. So what we will store, 0 0 0 7 into the D pair. So what this will do, this will add the content of D pair with the content of HL pair, and it will store the result in the HL pair. So what previous value of HL pair is 0, 0, 0, 0, and the multiplicand is 0, 0, 0, 0, 7, and these two are going to be added, and the result will be 0, 0, 0, 7, and it will be stored in the HL pair. So now what we are going to do, we are going to decrement the value of C. Since the multiplier value is 2, now when we are going to decrement it by 1, so it will become 1. So the C will become 1. Jump on no 0 back. Since the value of C register has not become 0, it will come back. And again, when it is coming back, what it is going to do, it is again going to do DADD. So what is DADD? It is again going to add the content of DE pair with the HL pair. Now DE pair is already 0007 and HL pair is the previous result, that is 0007. So 00007 will be added with 00007 so that it will become 0014. Now the next time decrement C, so C will become 0. When C will become 0, it will not go back, it will come out, and we are going to store the result. Now result will, where will be the result? Result will be in the HL pair. So what we are going to do, we are going to store the result in the memory location 2500 and 2501. By which instruction? By using SHLD. What this will do? It will store the content of HL pair at 2500 and 2501, and it is going to end the program. So this is the simplest program for getting the multiplication of two 8-bit numbers. Now you will find this multiplication program many places. You will get on the internet, you will also get in the books, but this is the simplest program. If you go through that, you will have clear understanding, and then you are able to write. Whenever any problem comes related with the multiplication, you only follow this particular flowchart as well as this program, and this will solve your purpose. Don't bother about any other program. It will create unnecessary confusion. The same way, since we don't have any instruction by which we can divide the number, so as we have written the program for the division of two 8-bit numbers. Of course, in case of multiplication, what we are doing successive addition. But in case of division, what we will do, we will be doing the successive subtraction. So if we don't know, since the microprocessor is unable to know what is the multiplication and what is the division as far as 8085 is concerned, since it does not have any instruction like multiplication or the division. So multiplication is being obtained by using successive addition, and division is being obtained by using the successive subtraction. So let us first discuss the flowchart of the division program. Now the flowchart says that now in case of division, we call the value which as dividend as well as the divisor. Divisor वो होता है जिससे divide किया जाता है, और डिविडेंड वो होता है जिसको डिवाइड किया जाता है. तो इसमें दो वैल्यू और रिजल्ट के फॉर्म में हमको मिलती है. एक होती है कोशेंट और दूसरी वैल्यू होती है रिमाइंडर. So we will store that quotient as well as the remainder. So for that, after initializing the value of dividend and the divisor, we have initialized the value of the quotient as 0, 0. और जितनी बार हम सब्सट्रैक्ट करेंगे डिविडेंड में से डिवीज़र को, उतनी बार कोशेंट की वैल्यू हम बढ़ाते जाएंगे. तो सबसे पहले हम क्या करेंगे, डिविडेंड में से डिवीज़र को घटाएंगे, और जितनी बार ये काम करेंगे उतनी बार कोशेंट की वैल्यू को हम बढ़ाते जाएंगे. So dividend is equal to dividend minus divisor, and the next is quotient is equal to quotient plus 1. Now ऐसा करते करते ऐसा हो सकता है, जब हम डिवाइड करते जाएं तो ऐसा हो सकता है कि एक समय ऐसा आएगा कि डिविडेंड की वैल्यू डिवीज़र से कम हो जाएगी. फॉर एग्जाम्पल, इफ़ यू हैव 0.7 एज डिविडेंड and 0.2 as divisor, so what we will do, first of all we will subtract 0.2 from 0.7 so that we will be getting 5. Now this 5 is again greater than 2, so we will again subtract 0.2 from the 5, so we will be getting 0.3. Then 3 is again greater than 2, so what we will do, we will again subtract 0.2 from 0.3, so we will be getting 0.1. Now whenever we are getting 0.1, now the 0.1 cannot be subtracted from 0.2 because 0.2 is greater. So what we will do, so that is why we are going to check the dividend has become less than divisor or not. If it is so, that value 1 will be the remainder, and the number of times we are subtracting the divisor from the dividend, that will become the value of the quotient. So since we have divided 3 times, so the quotient will become 3 and the remainder will become 1, and by that way we are going to store the quotient and the remainder at a certain place, and that will solve our purpose of getting the division of two 8-bit numbers. So let us go to the program. Now in this program, first the dividend value is stored in the accumulator and the divisor value is stored in the C register, and quotient has been initialized as the D register. So first of all, what we are going to do, we are going to subtract C. Now what subtract C will do? It will subtract the value of C, that is the divisor, from the dividend which is available in the accumulator. So suppose accumulator is having 0.7 and divisor is 2. So once it is being subtracted, so the accumulator will become 5. And when the accumulator will become 5, it means we have subtracted one time, then we will increase or increment the value of D, because one quotient is over. So quotient becomes quotient for previous value of quotient is 0, it will become 1. Then we will compare C. हम C को कंपेयर करेंगे. C क्या है? C डिवीज़र है. किससे कंपेयर कर रहे हैं? जो अब डिविडेंड है. डिविडेंड क्या है? 5 है. हम कंपेयर कर रहे हैं 5 को 2 से, कि ऐसा तो नहीं कि 5 की वैल्यू मैंने डिविडेंड की वैल्यू कम हो गई है. अगर कम होगी तो कैरी जनरेट होगा, और अगर कम नहीं होगी तो कैरी जनरेट नहीं होगा. तो जंप ऑन नो कैरी, वी आर गोइंग बैक. Whenever we are not generating any carry, jump on no carry, it is going to back. And what back is doing? It is again subtracting C. Now 0.5 will be subtracted. 0.5 is going to subtract. 0.2 is going to be subtracted from 0.5, so that the value will become 0.3. And we will increase the content of quotient. So content of quotient, previously it was 1, it will become 2. Now then we compare again. 0.3 is greater than 2 or not? It is greater than 2. If it is greater than 2, carry will not generate. So it will again go back and it will again subtract. And this process will move till the value of dividend will become less than the divisor. And when it is so, carry will be generated. And when the carry is generated, what we are going to do? We are going to store A into H and D into L. What is A? A is the remainder. And what is D? D is the quotient. So quotient is stored in L register and the remainder is stored in the H register, and the program is going to end. So this is simple program for the 8-bit division. Now you will find many programs, many flowcharts, many strategies by which division can be done, but this is the simplest way of writing a division program. So don't be confused with any program, and follow simply the multiplication program is concerned as well as division program is concerned, the flowchart as the program which is given in this particular video. I have already sent all of you the PowerPoint presentation of this also. Now the next one is program which is the program for the division of 16-bit dividend. If we have 8-bit divisor and dividend is 16-bit, then how this program is going to work? So there will be a little bit change I have to do, because it will be a longer process, because if the dividend is 8-bit and the divisor is 8-bit, then it is easy to perform the work. But if the dividend is 16-bit and the divisor is 8-bit, then it will take more time to get the solution. So first of all, let us go to the flowchart. Flowchart is simply as the previous one. There is no change in the flowchart. Whatever is the flowchart given in the previous program, but there will be change in the program also itself. Now the program is written as LHLD 8500. What does it says that 8500 और 8501 पे हमारा 16 बिट का डिविडेंड है, जिसको हम HL पेयर में स्टोर कर रहे हैं. So what it is going to do? It is going to load HL पेयर directly by 8500. 8500 वाला कंटेंट L रजिस्टर में, 8501 वाला कंटेंट जो है वो H रजिस्टर में, यानी HL पेयर रजिस्टर में हमारा 16 बिट का डिविडेंड आ गया. एंड देन वी आर डूइंग LDA 8502. ये कंसीडर किया जा रहा है कि 8502 पे हमारा डिवीज़र है, उसको हमने एक्यूमुलेटर में ले लिया. और हमने क्या किया, कि कोशेंट की वैल्यू को हमने इनिशियलाइज कर दिया और इसको भी 16 बिट के रजिस्टर में रखा है, दैट इज DE पेयर. सो इट इज़ क्लियर फ्रॉम दिस पर्टिकुलर पॉइंट. नाउ मूव AL. अब जब भी हम डिवीज़न कर रहे हैं तो डिवीज़न हम यहाँ पे सक्सेसिव सब्सट्रैक्शन के माध्यम से कर रहे हैं. सो इट इज़ वेरी सिंपल. तो हम सब्सट्रैक्शन जब भी करेंगे तो हम लीस्ट सिग्निफिकेंट की तरफ जाएंगे, हम लीस्ट सिग्निफिकेंट पे ही हमेशा सब्सट्रैक्शन करेंगे. इसीलिए हमने क्या किया है कि सबसे पहले मूव AL करने का मतलब है L में हमारा 16 बिट नंबर का लोअर बाइट है. अब हम क्या करेंगे कि इस लोअर बाइट को हमने क्या किया, एक्यूमुलेटर में डाल दिया. सपोज करिए कि हमारा 16 बिट का जो नंबर है वो है 1342 और हमारा डिवीज़र जो है वो है 02. अब 02 को हम 1342 में से तब तक घटाते जाएंगे जब तक कि वैल्यू डिविडेंड की 02 से कम ना हो जाए, और जितनी बार ये हम घटाएंगे उतनी बार हम कोशेंट को बढ़ाते जाएंगे. सबसे पहले हमने क्या किया, सब्सट्रैक्ट C किया. तो जब भी हमको सब्सट्रैक्ट करना होगा तो सब्सट्रैक्ट हम L रजिस्टर के कंटेंट से ही करेंगे, क्योंकि 1342 अगर 1342 नंबर है और उसमें से 02 को घटाना है तो एक्चुअली में आप देखिएगा आप 42 में से ही 02 को घटा रहे हैं. दैट इज़ वाई L रजिस्टर के कंटेंट को एक्यूमुलेटर में लिया गया है और फिर C रजिस्टर के अंदर हमारा डिवीज़र है उसको उससे घटा दिया गया. अब घटाने के बाद 42 में से जब आप 02 को घटाएंगे तो रिजल्ट क्या आएगा, 40. ये 40 रिजल्ट कहाँ पे होगा, एक्यूमुलेटर में. तो इस एक्यूमुलेटर की वैल्यू को हमको L रजिस्टर में वापस डालना है, क्योंकि ये एक्चुअल में नेक्स्ट लूप के लिए, नेक्स्ट टाइम के लिए डिविडेंड का काम करेगा. इसके बाद चूंकि हमने घटाया है तो हो सकता है कि 42 चूंकि बड़ा था 02 से इसलिए कैरी जनरेट नहीं हुआ, लेकिन अगर 42 की वैल्यू डिवीज़र की वैल्यू से कम होगी तो कैरी जनरेट करेगा. तो कैरी जनरेट अगर होता है तो जंप ऑन नो कैरी स्किप, और अगर कैरी जनरेट होता है तो ये क्या करेगा, कैरी जनरेट होता है तो उसको एक बोरो करना पड़ेगा, यानी 1342 में से ये घट करके ये 1242 हो जाएगा. तो इसकी वैल्यू H की वैल्यू जो है थोड़ी एक कम हो जाएगी. और अगर कैरी जनरेट नहीं हो रहा है एज इन दिस पर्टिकुलर केस जो हमने एग्जाम्पल लिया है, तो ये कहाँ जाएगा, स्किप पे जाएगा. स्किप क्या कर रहा है, INX-D. ये कोशेंट को चूंकि हमने एक बार घटाया है इसलिए हमने कोशेंट की वैल्यू को 1 से इंक्रीज किया. कोशेंट हमारा कहाँ है, DE पेयर में, इसलिए हमने INX-D किया. इसके बाद हम क्या कर रहे हैं, H की वैल्यू को A में ले रहे हैं, क्योंकि ऐसा होगा कि 1342 हमारा डिविडेंड है और 02 हमारा डिवीज़र है. तो हम घटाते जाएंगे घटाते जाएंगे घटाते जाएंगे घटाते जाएंगे. एक समय ऐसा आएगा जबकि HL पेयर H की वैल्यू कम होते होते, L की वैल्यू तो कम होगी, H की भी वैल्यू कम होते होते 02 से कम हो जाएगी. इसीलिए हमने क्या किया है कि H रजिस्टर के कंटेंट को एक्यूमुलेटर में डाल दिया है और इसको 00 से कंपेयर कर रहे हैं. हम ये चेक कर रहे हैं कि कहीं ऐसा तो नहीं कि डिविडेंड की वैल्यू डिवीज़र से कम हो जा रही है. अगर ऐसा है तब तो हम आगे बढ़ जाएंगे, और अगर ऐसा नहीं है तो ये वापस फिर से बैक पे चला जाएगा, और बैक पे जाएगा तो फिर से L एक्यूमुलेटर में आएगा, सब्सट्रैक्शन होगा. फिर सब्सट्रैक्शन होने के बाद जो रिजल्ट होगा वो L रजिस्टर में जाएगा. अगर कैरी जनरेट नहीं हुई है तो वो स्किप करके INX-D पे आएगा, और फिर H की वैल्यू को A में लेकर के फिर से हम कंपेयर करेंगे. और ये प्रोसेस चलता रहेगा. कब तक चलता रहेगा, जब तक कि डिविडेंड की वैल्यू यानी H की वैल्यू 00 डिवीज़र से कम ना हो जाए. और जैसे ही ये वैल्यू डिवीज़र से कम होगी उस समय L रजिस्टर में जो हमारा कंटेंट होगा उसको हम एक्यूमुलेटर में कॉपी कर लेंगे. और जब हम एक्यूमुलेटर कॉपी कर लेंगे तो हम चेक करेंगे कि हमारा जो डिवीज़र है जिस रोज की C रजिस्टर में है वो उससे छोटा तो नहीं है. अगर ऐसा नहीं है तो ये वापस चला जाएगा, और अगर ऐसा है तो हम क्या करेंगे, जो कुछ भी वैल्यू है उसको हम HL पेयर की वैल्यू को 8602 पे स्टोर कर लेंगे जो कि हमारा रिमाइंडर होगा, और उसके बाद एक्सचेंज करके हम 8600 की वैल्यू को हम HL पेयर की वैल्यू को हम 8600 और 8601 पे स्टोर कर लेंगे. In this way this program will work. But this second program will work only if the dividend is 16 bit. But if the dividend is 8 bit and the divisor is also 8 bit, then the second program will work. Otherwise, if the dividend is 16 bit, then only the third program will work. Otherwise, you can go with the second program. Okay, thank you.